Problem F18-9, the 60 kilogram rod is released from rest when theta equals 0. So it's up here. And determine its angular velocity when theta equals 45. The spring remains vertical. So it starts up here, the spring would be over here, and as it swings down, the spring slides over in that slot. So starting out at T1 plus V1 plus U equals T2 plus V2. There is no work being done. It starts from rest, and so we start out with U1, which U1 is up here, so that's mgh1 equals 1/2 I omega squared, that's the kinetic energy of it swinging, plus mgh2 plus 1/2 kx squared. Now, when it slides down, swings down, if we call that point 0, then this one goes to 0. And all we have is h1 being this height here. So that is the midpoint there is going to be half of 3, so 1.5 times the sine of 70, or 45, which is 0.707. And so that height 1 is 1.06. So m is 60, 9.81 for g, and a height of 1.06. 1/2 I for the end of a thin rod is 1/3 ml squared, which is 1/3 60 times 3 squared, which is 180. So 1/2 of 180 omega squared plus 1/2 k 150 and x. So we need the stretch. It's unstretched when it's up here, so this is the stretch, which is going to be twice that. So it's going to be 2.12 squared. Solving for omega, and omega equals 1.79 radians per second.